So example 3 from chapter 8, this one deals with proportions. The subject of the problem here discusses a color television set in which the manufacturer claims, this is important for chapter 9 later on, claims that the sets that they make last at least 5 years without needing a single repair. So a consumer group goes out and they find a sample of 400 of those customers who bought those TVs, and the results showed that 316 say that their color TV didn't need a repair in the 5 years, whereas 85 said they did. So those are the details of this particular problem. So the first part says find a 99% confidence interval for all color television sets that have lasted for 5 years. So in this particular case, we're looking to create a confidence interval around a proportion. And so I remind you of the formula P bar plus or minus Z alpha divided by 2 multiplied again by the standard error, but in this particular case, it's the standard error for the sampling proportion. And if in the rare occurrence they tell you what the population proportion is, I usually write it as 1 minus pi multiplied by pi divided by n. So mu is the population mean and pi is usually the population proportion. In this book, they use p, which I find confusing because the sample is also p, but except with a hat. So I don't like to use Latin letters for parameters. So for me, mu is the population, x bar is the sample, pi is the population, p bar is the sample. So if you see those notations, please don't get confused. So step 1, let's figure out what that proportion is. That's simple. It's 316 divided by 400, which gives you something like 79. Okay, so then we need to figure out what Z is and if we need to use the Z value. Well, we need to use the Z value because if you remember, n times p tells us if a sample is large, and n times 1 minus p also has to be done in order to confirm that the sample is large. And so in this particular case, 400 times 0.79 is certainly greater than 5, and 400 multiplied by 0.21, which is the complement, is also greater than 5. So both of those have to be confirmed, and once they are, we know that the sample size is large, and therefore we can use the Z value. So this is the 99% confidence interval, so Z1 divided by 2. And I know we've done this before many times, so I'm not going to waste your time looking it up in the Z table. The answer to that is 2.575. And once that's done, I go ahead and multiply by the standard error. Now, in this particular case, since we do not know the population proportion, what we're going to do is we're going to use the sample as an approximation. That's pretty simple. So 0.79 multiplied by 0.21 divided by 400. You do the math, you get to create an interval. Here is the population, the sample proportion, which we use as a point estimate, just kind of a reminder. So this is the point estimate. So this is the closest thing you have to a population parameter value. And so the upper limit is going to turn out to be something like 0.842%, whereas the lower limit is going to be 0.738. So you are 99% sure that the population proportion pi is somewhere here, and there is a 0.5% that it is anywhere on the outside. And speaking of which, the second part says, does this confidence interval provide strong evidence that the percentage of color TV sets last at least 5 years? Well, just like the problems we've solved before, we need to look at where this interval is and where is our cutoff mark. So we are looking for 95%, but if you can observe here, we can see that the population proportion is nowhere near 95%. 95% is much out, it's much further out than the sample has provided us. It is somewhere here. So it's telling us that the true population proportion is somewhere between 70 and 80%, or 74 and 84%, nowhere near the 95% that the claim makes. So yeah, actually there's strong evidence that the claim is incorrect because it falls very far outside the interval.